Yo, GM everyone, I'm Justin, and over the weekend I worked on a little side project that was inspired by a conversational tweet between Anatoly and Dean, where they were talking about how to reduce a sniper bot in protocols that are quite similar to how Pump.Fun works. And Dean suggested a solution that is quite similar to how Jupyter Alpha Vault work, where once a token has been determined, alpha vault will be available for a certain period of time, and anyone can deposit SOL into this vault. And once the vault closes, all the SOL will be used up to purchase the token at the lowest possible price, giving all early depositor the lowest possible average. So I thought it was quite interesting, and decided to build it out. I get to work on got to play with Radiant protocol as well, which is quite interesting. Quite a lot of learning points. The entire code will be available on my GitHub. I will be posting the link in the description below. Yeah, so in this video, I'll be walking through my thought process, and if you wish to clone the GitHub and adjust it a little bit and launch your own pump fun like protocol, go ahead, guys. So without further ado, let's get started. I will not be going through things like the business logic of this code base. I will only be covering the important high level part. If for the business logic, feel free to read through it and you can adjust it however you want. But yeah, so starting with my thought process on building this program out. Now, I really like the idea for any Web3 program, right? I really like the idea where one program can be, there could be many websites supporting one program, and each website is customized to its audience. So, for example, if their target audience are Japanese, the entire site could be tailored in Japanese and basically a UI that's familiar to the target audience. And because of that, I did create something little unique. I think it's quite unique, where there is a creator share fee and a user share fee. So basically, they are referral fee. So imagine your target audience are a bunch of let's say they speak a certain language, right? And you can create a website that is in their native language, and you and the use any creators can come on and launch a token on your through your website. And because they launch through your website, you will be the referral, because it's just a param. When you construct the instruction, it's just a field that you passed in. So if you are the creator referrer, you do get a fee. Similarly, if you refer the user, you will get a user fee. But collectively, all website, they all share the same database. All right, they share the same state, which is a single program. And this way you have liquidity, you have volume, you have activities that's going on, that's put together through multiple website, but each website is actually incentivized to uh, attract people in, all right, attract their own audience. So that's the slight difference, slight uniqueness that I have for this program. Uh, and at the very top, now this is the global state that I'm going through. So this global state basically store any global configuration, such as the master authority and config authority. I like to have two different authority or even more authority, because usually for the config authority is to make a low risk decision or low risk configuration, whereas the master authority is the one that ideally will be a multi-sig, and the config authority, which is it could be held by one single entity or one single person. A treasury is where your fees will goes to. There's a fee BPS, which is fees basis point, where every single transaction or every single alpha deposit, this fee will be taken up and put into the treasury. There's a curve multiplier as well. Now to put it out there, I'm not very familiar with how bonding curve algorithm works, so I just took a snippet template from ChatGPT and pasted it there. You do need to check it out and do need to adjust it accordingly. Graduation lamport is the amount of lamport needed to graduate a pool. So I believe the graduate amount for pump fund is around 80 SOL. Could be wrong. And alpha duration is the time, a duration that the duration where the alpha vault closes. So yeah, it could be 5 minutes, could be 5 seconds, could be 5 days. It's really up to you. Yeah, we've gone through this, and yeah, this one is the protocol state. So I like to add this in for all the program that I create, because I read it somewhere that this I can't remember who posted it. I believe it was I can't remember. I don't want to get it wrong, so I'm not gonna try to recall the name. But yeah, so there was some awesome chat that, Solana chat that posted a tweet about having this in place, where in case of an emergency such as a hack, you want to have a quick way to toggle off the program. So over here we have the normal operation and we have hot. So in a case where a hack is occurring, some malicious activity is happening, you are panicking, you want to have a very quick and simple way to shut off the entire program. It's literally an on-off switch. So this is so that it gives the developer and all the team enough time to compose themselves, get to push a fix out. Yeah, and well, these are the standard stuff: bump version padding, and reserve. Reserve is basically in case in the future we want to add more fields, such as maybe we want to add 2 or 3 more pub keys, then we can just reduce the size over here and add it accordingly. The next PDA we have is the bonding curve. So the bonding curve holds, well, I will not go through all this stuff specifically. You guys can just read through it. It basically holds information for a specific bonding curve, and the user deposit is unique to each bonding curve. So one user can have many user deposit up to the number of bonding curve they deposit into. Okay, so we're gonna looking at the lib.rs file. I will not be going through all of them. I will only be going through the important parts. So things like init global is just value assignment. That's not important. You can go through it yourself. So same for update authority. There's 2 update to the global, is because this is a habit of mine where I have a upgrade authority that require the master authority to be the signer to change the config authority, and for the normal update authority, the config authority has the right to do it as well. Okay, so the first important part, initializing of the bonding curve. So let's see, what's this? Okay, so at the first we have the assignment, variable assignment, standard stuff. Okay, then we are gonna create the mean over here. So when we initialize the bonding curve, we will be creating the mean. At the same time, we are creating the metadata as well. The metadata are things such as the name of token, the symbol, the image URI, whether they are fees or not. So we are using, in this demo, we are using the Metaplex metadata program. You do need to make sure you import the crate. Let's see, what's the anchor file. Not this, what am I doing? Sorry, I can't really see it from the camera blocking me. Alright, there we have it. Okay, you do need to have the Metaplex token meta data as the dependency. Then you'll get access to this. The Metaplex docs is really straightforward, so just need to can read through it and populate the field that we want. It's quite self-explanatory. What's the mean authority? In this example, the mean authority is the bonding curve. So once we initialize this, we need, because the authority is a PDA, we need to invoke sign. Okay, we need to provide the signer seed. Once that is done, we have already initialized the metadata. We would min the token. So we min 1 billion tokens with 6 decimal place, because that is what PumpFun uses. And we set the authority to none. Okay, that means we revoke the min authority. Means this token is fixed, right? And yeah, that's pretty much it. We initialize the bonding curve, we create the metadata, and we min the token. So yeah, that's pretty much it. So next up we have the claim fees. Okay, so claim fees make more sense for the claim fees to go below, because you do need to have deposit, you need to have fees before you can claim it. So maybe we'll go through the alpha deposit first. So this is when a user deposit SOL into the bonding curve, alright, to the alpha vault. So first thing first, we would let's see what I do here. Over here I check whether the user deposit has been created. If it has not been created, we will initialize it, assign some variable, and if it is, we just return the mutable account. So afterwards we check whether the time it is valid, whether the vault has closed or not. If it's available, we will then do some logical tests, do some assignment value, take the fees out, so on and so forth. If not, alright, if the vault has closed, if not, we would get how much tokens can we purchase from the total deposit. Alright, using this formula over here, calculate price. Once again, you might need to check all this price calculation, because I got this all from ChatGPT. It's very likely there's 100% there's a better way to go about that, but hey, the objective that I want to show is to practice on how to call some invoke into Radium. So yeah, so what's this? Bonding curve launch time. Yeah, so wait, what's this? Bonding curve load. Okay, after launch time. That means that launch time is over. Hey, if it's not over, alright. Yeah, that means it's in the past. It is not. If it's not, I will transfer. Correct. So if it's not over, that means it is still accepting a SOL token into the vault. It will call the SOL transfer system transfer method, where we transfer SOL from the authority, which is the user, and transfer it into the bonding curve. So this bonding curve now, this PDA have more SOL, alright, and that's pretty much it. What's next? Alpha claim. So alpha claim is you can only do this after once the bonding curve close. Yeah. So when this is assigned, or when the alpha vault is over, we will allow the user to claim it. We'll transfer the token from the bonding curve ATA. That means this is where the 1 billion token sits, and transfer it to the authority ATA. So we're transferring the token to them because they claim it. That's great. Then we'll just adjust the amount that's being claimed. Yeah. Claim fees. Let's see, any important stuff. Not really. They are all just okay. So one really interesting way that you need to note about when we want to transfer SOL from PDAs, we need to use the sub-lamp port, or you can add lamp port. We cannot use the system transfer method. It's gonna throw an error about like from can't be from, which is the sender. The sender cannot be a PDA. Alright, you're gonna get an error like that, so you have to do this instead. Yeah, this is very important, because later on when we talk about how to initialize a Radium program, initialize a Radium pool, this problem is going to come out. So take note of it. Okay, so we run through handle fees. Next up, buy and sell. Yeah, let's see if there's anything important. Transfer SOL. Yep, if the user transfer the bonding curve some SOL, the bonding curve will transfer the user some token. Yeah, so over every now and then you will see things like all this curly bracket that is wrapping it around. let me see if I can find another example. Yeah, so over here, so you can see that I'm doing things like a curly bracket over here. The reason we need this is because we need to drop some value out of scope. If not, Rust is gonna throw an error, because we can't really, if we are gonna mutate a state, we have to drop it before we can reference it. So that's just a way to get around it. Now over here, you notice that buy and sell share the same validation. You can do that as to save some memory space, since they both use the same account validation. There's no need to repeat your code. Alright, so this is where it gets really interesting and took me a while to figure it out. So now that we have the bonding curve has the alpha vault has opened, it has closed, the bonding curve is available for purchase, and that's great, right? People buy and sell, things like that. So now the final step is for us to take all the SOL that's in the bonding curve and all the token that's in the that's remaining in the bonding curve ATA and transfer it into Radium AMM to create a pool. All right, create a pool and transfer all the asset over. So how I did it at the start was that we have a graduate pool endpoint, and so at the start we have the lamp pods is in the bonding curve, all right, but we need it to be in Repsol, which is a SPL version of it. So for that to happen, we need to convert the SOL in the bonding curve to Repsol. We can do that by calling a function called syncNative. Okay, that's quite straightforward. But here's a couple of problems. The first one is when we transfer a token from so first step, we need to transfer the bonding curve lamport into a bonding curve Repsol ATA account. Once we make the transfer, we can call the syncNative to convert the lamports into Repsol. Now, here's where the first problem lies, right? We can't call when we transfer a token, we can't call syncNative directly because the transfer actually mutate the lamport state, and the Solana runtime, SVM runtime, actually doesn't allow that. So that was quite annoying, and after some reading, I noticed I found out that it's sort of like a known issue that we can't really get around. The only way to get around it is that you need to sorry, let me summarize it better. So if you want to adjust any lamport, you can't call any CPIs. So let me see, how do I explain that? Okay, so you can't call if you want to call any CPI, it has to be done before the lamport has been adjusted. Yes, okay. So when we call syncNative, we are actually calling a CPI. So and because we adjust the lamport before that, we adjust the lamport, we can't call a CPI anymore. We can't call syncNative. We can call syncNative first and then call send the lamport over, but that doesn't make sense because we need the lamport to be in the Repsol ATA for us to convert it. Therefore, the solution around this is for me to transfer the lamport into the Repsol ATA first, and then call a second instruction to convert the lamports into Repsol. Okay, so that's what I did. Okay, so we transfer. Okay, so here's another problem. Before I go into that, I'm just gonna show you guys that's how I transfer. I transfer the bonding curve SOL into the Repsol ATA, and that's the end of the instruction. And then in the next instruction, we're gonna sync it. Okay, so another interesting part over here is that if we look into the, let's see, yep, So this is the radium initialize endpoint. This is the instruction that we want to call. We want to call the initialize instruction. So we do need to pass all this pass this information data in. But here's the tricky part. The creator over here have to be the payer. You see this? There's quite a few accounts that need to be created. See, you need to create a pool state. If needed, you need to create the LP min. You need to create a token, or like, you know, all this stuff. So that means that our bonding curve PDA need to have some SOL remaining, because previously we thought that we're just gonna transfer the entire Lamport amount and the entire remaining token in the ATA pool and transfer it over to initialize the bonding curve. But that's not the case. We do need to make sure there is sufficient rent in the PDA remaining to pay off the rent, and then pass on the remaining SOL wrap SOL to the Radium pool. So since that's the case, we just simply calculate the amount of rent that's needed. Once we got the total rent needed, we calculate how much is in the bonding curve, and we take the amount. We subtract it from the we subtract the amount that we want to convert into Repsol from the bonding curve, and we add it into the Repsol ATA. Okay, sorry, went a whole round, but rewatch this this past few minutes to get a better understanding. And next up, we're gonna call the graduate pool. All right, so now we have the Repsol ATA, the bonding curve Repsol ATA have some Lamports, which we need to convert it into Repsol. So how do we do that? So over here, what we did was we did some tests. Okay, not important stuff. Okay, we call the sync native over here. This is how we call sync native. We create an instruction, sync native instruction, by passing in the token program and the account that we wish to convert the Lamports into Repsol. So we call the instruction, and great, done, that's it, right? We have converted the Lamport, the SOL that's in this account, into Repsol. Now here, this is where things get a little bit tricky. So remember just now when I mentioned that when we want to transfer Lamports transfer SOL from one account to the other account, we cannot use the system transfer method. It's gonna throw an error saying that from cannot hold data. That means that from cannot be a PDA. Let me see if I can find the code over here. Yeah, so this area. So you see, it calls system transfer and the creator key. So to my understanding, if I understand this correctly, that means that the creator cannot be a PDA. Alright, because it's gonna fail in this line over here. So what we need to do now is we need the creator to be a key pair. So how can you do that? So the workaround is I transfer all the Repsol into a key pair, the authority. Okay, so that means that whoever owns this authority private key has the right to just pull liquidity out and run away with it. Okay, so that's why we need to burn. Okay, I did not add the burn LP, so we need to add that in afterwards. And maybe you guys can add that in. But yeah, just take note that the reason why we can do this is because all these instructions are encapsulated into one Solana instruction. Okay, so it's atomic. So as no one can really insert another instruction in between all these calls. So we just need to make sure that we transfer a token, we create the AMM, the new pool, and we burn the LP token in one instruction. So yeah, so we transfer the Repsol into the authority, we transfer the token into authority, Okay, over here you can see the example that I use invoke over here. I use the native call instead of anchor. This is how you do it. You may, if um, anchor does have a little bit of overhead, that means it consumes a little bit more compute unit. So if that's a concern, just note that having a few more lines of code makes your code a little bit more efficient. Yeah, so this part is basically how how Radium handle which token comes first. How Radium manage the pool where, let's say you want to have a Sol and USDC pool. Technically, you can have a Sol USDC and USDC Sol. So how Radium manage this is that they make sure that token 0 is a smaller value than token 1. So we just need to do that check. And alright, this is where we call the Radium initialize endpoint. So I'm not using the Radium SDK because they were giving me some anchor version issue, so decided not to look into that. Just this is just simpler for me. So just all you need to do is you need to have a discriminator. This points to this endpoint. Okay, so for all Solana program endpoint, all you need to do to find the discriminator is to basically turn this string global colon and an endpoint name. So in this example, this program example, the claim fees discriminator would be global colon claim fees small letters. Okay, once you convert that, you're gonna get some value like this. This will be the discriminator to point to that instruction. We pass in the value that's required. We can get this from the initialize. Yeah, so it's over here. It require init amount 1, init amount 2, and open time. We get that. We pass in the accounts that's required. Make sure that all this information matches the anchor validation we see in Radium program. And we push the accounts that's needed, and we invoke. We call it. So once you call it, we need to burn the LP. Okay. So yeah, and that's pretty much it. Yeah, so this entire program it works. I already tested the script. You can clone it, run the script if you want to, just to make sure that you need to uncomment this initialize global state, and on the subsequent run make sure you comment it out. Yeah, so that's pretty much it. If you're do give me, if you have any feedback regarding this program, drop in a comment below. I would love to learn, improve how I work on my coding, how I structure my code as well. If you have any thoughts about it, drop in a comment below, open the feedback. And if you got any question, or even like if you have any question about this program, feel free to reach out to me either via Twitter. Gonna put my handle in the description below. And yeah, I hope you guys enjoy it, and I'll see you guys next time.